Hi everyone, welcome back to Stardust Discovery. I am Adeze Ibik, also known as Astro Princess. Today I would like us to look into another topic in the series of trying to solve physics questions, like we started with the 2021 WASSCE Certificate Examination questions. We started with the part 1. And today we will be starting with the part 2. And the topic for part 2 is Hooke's law. I know we treated this topic at some point when we were solving part 1. So you can check the video if you are interested. But I will be building on that while trying to remind us some of the ideas of the concept of Hooke's law as well. Okay. So the question is here. The first question says, state Hooke's law. Now, if you remember from what we know about Hooke's law, it has to do with elasticity. It's a law that tries to tell about the relationship between elastic material and any object that interacts with it. So specifically, stating Hooke's law involves linking the force and the extension that is created. So I've given the explanation of the law as I'm showing on the screen, that Hooke's law states that the force or load needed to stretch a material or an elastic material is directly proportional to the extension of the material, provided the elastic limit is not exceeded. This is more like a condition for this law to hold. And then you can include this equation that describes what I just said. Force equal to the force constant, which is also the constant of proportionality times the extension. So if you are able to state this law correctly without mixing things up, for example, the load and the extension, their direct relationship has to be established. So if you're able to connect the two together, you should get your full marks. So typically, questions like this would have 1 mark. So you should get 1 full mark or 2 full marks, depending on what mark they decide to apportion for this. But if you make a mistake that is crucial, for example, if you, instead of saying directly, you say inversely, then you have deviated so much from the real definition, and that will make you to fail this question. So you get a 0. So unfortunately, for questions that are related to laws, because of how important laws are, it's difficult to cut the mark into bits. So it's either you get it or you don't get it, so that if you make a mistake, you get a 0. But when you state the law properly, you should have your full marks. The equation is not compulsory, but depending on the year, there are some years where they could state it explicitly that you should include equation, while sometimes you don't. And there are even some people that would not even state the laws in words. They would just use equations, put it there. So I would recommend that you combine both writing it in words and putting the equation. It shows that you know what you're saying, that you did not just make it up. So I would advise against just typing the equation or writing it that way without putting it in words. At the same time, I would suggest that you include the equation even after writing the words. That way, no matter the strategy or the standard adopted for the year, you would still scale through by all standards. So, okay, so that's it for number 8AI. You can see that this question has a lot of children. So you expect all the AII, all those type of things in section 2 or in part 2. Okay, so let's get into the next one. So a spring has a length of 0.2 meters when a mass of 0.3 kg hangs on it. So this is saying that when you hang a mass that is weighing 0.3 kg on a spring, the new length of that spring will be 0.2 meters. So I think it's useful to illustrate what you are reading by drawing a diagram. So here I have tried to draw this diagram to make it easier for you. So there is a spring of length, original length L0. Now if you hang a mass M1, in this case the M1 here is 0.3, there would be a stretching. The spring would stretch, and so that the new length L1 will have the addition of that extension. So extension which was caused by that mass is given by the L1 minus the original length. Okay, then there is a second setup and a length of 0.75 meters when a mass of 1.95 kg hangs on it. So this second setup is saying that when you hang a mass of 1.95 kg, in this case M2 is the 1.95 kg. So if you hang that mass on this spring, it will stretch it even more. If you notice from this diagram, this particular one is stretched further, so that you have a longer extension created. So this extension is gotten by the new length L2 minus the original length L0. That's what gives you this extension. So in general, this diagram does not necessarily give you extra marks, but I think it's useful just so that you can visualize what you are doing. However, you have to keep an eye on the question. If the question is explicit about you drawing this diagram, that means it will have some marks, so you should draw it. But if there was no explicit mention of drawing, then it could be a bonus mark sometimes, or maybe there's no mark at all, but then it's just useful for you as you try to process the solution to the question. Okay, now in order to solve this equation, I would recommend you start from the original formula of Hooke's law. Hooke's law states that the force is proportional to the constant times extension, which is what I've written here. So, but what you are looking for in the first question is the force constant of that spring, which is the K. Now you need to rearrange this equation and make that K the subject of the formula. So that's what happened here. So K is equals to force over extension. So in this case, we are not just given the force and the extension. In fact, we have the force, because when you have mass, if you multiply the mass by the acceleration due to gravity, you get a force. However, we are given two setups, so you have like two forces. But then we are not given extension per se, but we are given new length. So it's important to check what you're given. It helps you to know the right formula to choose from. So that's why I had to go next to look at the given parameters. So like I said, you have L1, the new length when you have mass 1. You have L2, the new length when you place a mass 2. And I've explained that the extension will be L1, at least for the first extension, it will be L1 minus L0. And for the second extension, it will be L2 minus L0. So if you have the force and you have L2, but you don't have L0, and you also do not have the extension. That means you have two unknowns here. You need to find the extension and you need to find the L0, or one of it at least. So when you see questions like this with two setup, that automatically, and two unknowns, that automatically tells you that you need to create a simultaneous equation of that problem. So this problem involves two setup and it involves two unknowns. I just showed you the unknowns. You don't know the constant, the first constant, and you don't know what the extension is. If you know the original length, it will tell you what the extension is. So those two are connected, right? So here is how you should set up this equation. So you have your first setup. Let that first be your F1. When you multiply the mass by your acceleration due to gravity, which is given to you to be 10 meters per second square, that will give you F1. But here we are focusing on just the equations. You're not substituting yet. So you have F1 over E1. So if you open F1 up, you get M1 times G all over L1 minus L0, which should give you E1. Remember, we know L1, but we don't know L0. But we know M1 and G. We do not know K. So this first setup will be your equation 1. Now you set up the second one so that F2 over E2 will be M2 times G over L2 minus L0. This is your equation 2. So just expressing further, equation 1 could be rearranged so that it looks like this. When you have it this way, you can substitute the values that you are giving. So L1 is 0.2, M1 is 0.3, and G is 10. Solve this and then you can choose what to do from this stage. So I will take a break and let you remember how to solve simultaneous equation. In your mathematics, I'm sure you can remember there are different methods of solving simultaneous equation. So once you have two set of equations and there are two unknowns, it means you can use either elimination method or substitution method or matrix or any other. There are actually some method to solve it. So in this case, you are free to choose any method, but bear in mind the order with which the question was asked. So there is a way you can solve to find the length of the spring, the original length of the spring first, before you find the first constant, still with this simultaneous equation. However, I would encourage you to follow the sequence of the equation. So try to solve for the first constant first before you solve for the original length. Okay, so in order to do that, I would express this equation in terms of the original length instead of the first constant. So that gives me equation 3 basically. So with this equation 3 now, I can apply it into equation 2. Now what I'm doing is substitution method. I'm now substituting equation 3 into equation 2. So when I do that, I will get equation 4. Now, in terms of grading, getting the right formula from the beginning gives you 1 full mark. Every time, most cases, formulas have 1 full mark because that's the beginning of your success. The fact that you have the right formula at hand will most likely lead you to the answer. Okay. Now, because this equation involves some set of derivations, it could have extra marks assigned to it, but you never know. You just You only find out when they are marking it. But to be on the safe side, it's good to show all workings neatly and properly. But I will let you know that your ability to solve and get to equation 4 will give you another 1 full mark, because this equation is where you now substitute to finally get the answer. So getting the formula, 1 full mark, solving all the steps in between until you get to equation 4, or even a better way, it's either equation 4 or maybe you have now gotten to equation here. I didn't name it, but this next one where you have rearranged it so that you are finding k. So there is no hard way, like there's no one way to it. It's either equation 4 or that is looking somehow like one of these equations here. Okay, in this case you just need to now solve for k. So by rearranging and substituting the values you have, you will get 30 Newton per meter. So when you get to this point, this will be half mark. It's funny, right? Because like you did all these things, you went through all this struggle just to get a half mark. Well, the process is what matters in these theory questions. The workings, the process is what matters. So that's why you should not just put final answer and go away. You need to show your workings, because the final answer just have half marks sometimes, maybe 1 mark sometimes. But remember that if you do not have the right unit, you can also lose that half mark. So you need to make sure that your units are correct in the final answer. There is also what is it called now, the decimal places. So if your final answer has to do with, like, it has some decimals to it, you need to make sure that they are up to 3 decimal places. In our case, there is really no decimals. But if you have up to, let's say, 2 or 3, then you want to round up to make sure that you have at least 3 decimal places. If the question specifically tells you to round it up, that means after you have your 3 decimal places and an answer, you should now have a second answer, which would be the specific rounding answer. I just thought I should mention that. In this case, it's not needed, not applicable. Okay, so we just found the first constant. Now we are going to solve for the original length. That is the length of the spring when it is unloaded. So when you take away all the masses, what will be the length of the spring? Okay, so with that, you now have your k. You have those equations, equation 1, equation 2, and equation 3. Now any of them could be used. You can choose any one to find your original length, because you already have your k, and they should give you the same answer. It doesn't matter which one you choose. So in this case, in this example, we are using equation 3. So that new value you get for k, just substitute it into equation 3, which is what you have here, right? This equation, and that automatically gives you L0, and the value we have is 0.1 meter. So this is your final answer. And assuming this has so many other decimal places, then I want to show my answer in 3 decimal places. However, it does not, it's just 0.1. So that's what we have. Also, the unit, remember, is important. These values were given in meters, so we didn't do any conversion. Everything was already in SI units, which is good. Assuming you were given values in another unit, then you would need to do some conversion first before you start to solve. But in this case, we have them all in SI unit, which is good. Okay, so this is what we want to get to. For this particular question, you have 1 mark for this final answer. Most times the equation that leads to it have half mark, and then the final answer has half mark, making it 1 mark. Okay, and so depending on the year, these mark assignments can vary, so I'm trying to emphasize on what can give you mark and what can make you lose mark, as opposed to the actual mark that you will be given, because it can change from year to year. Okay, yeah, so in order not to bore you so much, I will leave this. We'll continue with solution in our next video, because this question has part B and part C. I think the whole question 8 actually is 10 marks. They assign 10 marks for this part 2 for each of the number. So, but we just solved part A, which covers Hooke's law. Okay, so that will be it. I hope this was clear and you make sense of it. Feel free to ask your question in the comment section, and then do not forget to subscribe to Stardust Discovery YouTube channel at Discovery Stardust. Comment, like, and share this video to your classmates and all those who are preparing for the WASSCE certificate examination, and this will be very useful for them. Okay, and then I will leave you with this one: the God's love is the anchor that holds you steady in the storms of life. So no matter what you're going through this moment, do not forget that God loves you. All right, thank you so much, and I will see you in our next one. All right, bye.